Okay, so today we will start with the second question of the heap. So the second question is last stone weight. Okay, so the question says you are given an array of integer stones. Stone I is the weight of the highest stone. We are playing a game with stones. On each turn, we choose the heaviest two stones and smash them together. Suppose the heaviest two stones have weights x and y, with x smaller than equal to y. The result of this smash is, if both stones are equal, then both stones are destroyed. If they are not equal, uh, then we got a new weight that will be equal to the y minus x. Okay, we get a new stone. At the end of the game, there is at most one stone left. Okay, means there can or cannot be a stone left after the activity. So return the weight of the last remaining stone. If there are no stones remain left, return 0. Okay, so what we are doing here is we are picking up two heaviest stones and we are smashing them. If both are equal, then there will be no new stone created, and if they are not equal, then a new stone will be created, which will be equal to the difference of the two stones. So first of all, we need a priority queue. Priority queue of integers. PQ and as we need two maximum stones, so we need max priority queue. Collections dot reverse order. Okay, so first we will put all stones into our priority queue. Okay, after that we will pop from our priority queue while our priority queue size is greater than 1. Okay, so if our priority queue's size is greater than 1, that means it at least contain two elements. So the first will be y element pq dot poll, and second will be x pq dot poll. So we have two conditions. First one is if they are both equal. So if they are both equal, then in that case we don't need to add any element, so we will do nothing in this case. And if x is not equal to y, then in that case what we need to do is we need to add to our priority queue the difference of y minus x. So that's what the question is saying, and at the end we will return if our priority queue size becomes 0, in that case we will return 0. Otherwise we have a condition that our priority queue's size is 1, so in that case we will return that last element. So I think this is the demand of the question. So let's see if this works. Okay, so our function reverse order. Okay, it is a function, not a attribute. So let's see if this works. Okay, so cannot find symbol integers. Okay, let's submit this. Okay, we have submission. So I think we can move to the next question. So the next question says k closest points to origin. Okay, so the question says given an array of points where point I, xi, yi represents a point on xy plane and an integer k, return the k closest points to the origin 0 0. Okay, so we have a points array where we have points on the Cartesian plane. So the distance is defined as the distance between two plane is equilinear distance, means or we can say it is a Pythagorean distance. So you may return the answer in any order. The answer is guaranteed to be unique except for the order that is in. Okay, so we need k closest point. So here we need one closest point, so we have this output. Okay, so as the question saying that we need k closest point, so closest point, so that means we need uh, we need k minimum distances. So this gives us a hint that we need to use min priority queue or min heap, I can say. Okay, so what we can do here is we can calculate the respective distance of every point and we can add that to the priority queue with index, so that we can identify that for which index we are adding the element in the priority queue. So we will be in our priority queue we will be storing the distance from origin and index of that point in the array, and at last we will remove k minimum elements from our priority queue, and that will be our closest points. So for that we need a priority queue. So let's initialize a priority queue. Okay, so we need a priority queue of integer array pq new priority queue. Okay, so I think by default the elements will be sorted on the basis of the zeroth element of the array which will be adding to the priority queue. So let's add distance of the points for int I is equals to 0, I less than points dot length I plus plus. So first we'll calculate the distance. So our distance will be, so as we can see that distance is given in the form of under root. So one thing we can say is if a element x is greater than y, then that implies that the square of x, in the case of positive number I am stating this, so then this will also be true in the case of positive integers. So instead of calculating the under root, we can simply calculate what is the under the root. So we can calculate that. So our x2 will be 0 and y2 will be 0 because we are calculating distance from the origin. So simply what we need is points of I 0 into let's initialize x1 as this and our y1 as this. So these are our points x1 and y1. So our distance will be x1 into x1, okay, and plus y1 into y1. So basically we have found the distance from the origin of the ith point So now we need to store this distance and index in our priority queue. So how we'll store this? We will add priority queue dot add new integer array we want. So in that array we want distance at the 0th index, because we want to sort on the basis of the 0th index, and index on the uh, one index, one at first index. Okay, so now we have added points to the priority queue. Okay, so as output we need this array. So I think we should also initialize our answer. So our answer will be something like so we need k closest point, so then we need array of size k, and at the end we will return this answer. So now we need to find that k closest point. So that k closest point will be top k elements in our priority queue. So we will pop from our priority queue while our k is greater than 0 and our priority queue has some element. So priority queue is not empty. Till then we will pop up from our priority queue, and what we will do, so our current pair will be, current point will be pq.poll. Okay, so now our win, so current 0th index will be, suppose we need a point, so we need index of the current closest point, so that will be pq.poll, and so this will return a array. This will return a array of size 2 in which our index will be at second position, means first index. So this is our index. Okay, so now we need to put something into our answer. So 0th point will be from the original points array. We have now index 0, and at 1st position we can put this 1, and also we need to decrement our count, kth count, and at the end we can return our answer. So I think this should work. Let's run this. Okay, we got some issue, so we don't have any I. So okay, so we need index in the answer array, so that will be, let's say, so our idx is okay, k will be this. Let's initialize index as j as 0. so after adding here we can increment it. Okay, or we can just increment it here. Let's see if this works. Okay, what issue we are getting? I think we need a comparator, or it's something else. Let's define a comparator. So it's easy to define a comparator. We have we need to sort it on the basis of 0th index, so we can define it this way. Okay, so basically we need to define a comparator. By default it will not sort on the basis of 0th index. Okay, let's submit this. Okay, we have a solution. Okay, so Now we will solve this question. Kth largest element in an array. Okay, so question says given an integer array nums and an integer k, return the kth largest element in the array. Okay, we need kth largest element in the array. Note that it is the kth largest element in the sorted order, not the kth distinct element. Okay, can you solve it without sorting? Okay, so we need to find the kth largest element without considering distinct element. So here we need second largest element. So first largest is 6 and second is 5. So our answer is 5. Similarly, here we need fourth largest element. So first is 6th, second is 5, third is also 5, and fourth is 4. So that's why we return 4. Okay, so we can also use a priority queue here, similar to the previous question, and we can pop k minus 1 elements, and then our peak of the array will be our kth largest element. But I think we should do it using another approach. So let's first solve it using priority queue. So it's simple using priority queues. So we need a priority queue of integers pq. We need a max priority queue, so we can reverse our priority queue. We can add all the elements of the nums into our priority queue. So now we need to pop k elements, k minus l 1 element. So while our k is greater than 1, and our, so here what we are doing, we are removing k minus 1 elements from our priority queue, and so we have two conditions, and our priority queue is not empty. So we will simply pull from our priority queue, and we will decrement our k counter, and at the end, if our priority queue is empty, then in that case I think there will be no case according to question, but for safety let's return -1 in that case. Otherwise we will return peak value of the queue. So I think this is the brute force solution for now, we can say. Wait a second, so we have a problem here. So we don't need integers, we need an integer. Okay, pq dot element we need to add, not priority queue itself. Okay, so we can submit this. Okay, but this is a slower solution, and also this is I think not the expected solution from us. So I think we need to solve it using a, we can say, selection sort algorithm, or it is a quick select algorithm, I don't remember. Okay, so what we will gonna do is, suppose we have this array. So what we will be doing is we will be for now considering last element as our pivot, and we will be sorting our array based on this pivot. We will be storing all the elements smaller than 4 on the left side and greater on the right side. So suppose this is 3, so we will keep 3 here because 3 is smaller than 4. Then we have 2, we will keep 2 here because it's smaller. We have now 1, so we will keep 3, 2, keep 1 here. Okay. Now these two elements we have. Okay, so till now we have found all the elements. So our pointer, which is keeping track where our smaller elements reach, is at one position. Now we reach 5, so we will just add 5. Okay, so we have solved this question using the what we can say, priority queue. So now we will, instead of doing it using priority queue, we can do it using quick select algorithm. So now we will do it using a quick select algorithm. So in quick select algorithm, what we do is we select an element. For example, we select a pivot. So for example, we select here 4 as our pivot. So what we will do, we will divide our whole array into two groups, one which is smaller than pivot and one which is greater than pivot. For example, here dividing into smaller, so this group is smaller than 4 and this group is 5 and 6 are greater than 4. So now we will in middle put our pivot. So what, after doing grouping the elements, what we can say is in a sorted array the position of 4 will always be this position which it is on now, which is now. So and we can check this position whether this position in the array is from the last is kth position or not. So let's say for example here k is 2, so we can check this is first position, this is second position, this is third position. No, the position of 4 is not the kth position, so this is not our answer. So now suppose we divide our array at pivot 5. So we put 3, 2, 1. Okay, 5 is smaller, greater than 5, so we will put 5 here, 6 here, and we put 4 here. So now as we can see on the left of 5, all the elements are smaller than 5 and all greater are on the right. And we can check if the position what is the position of 5 in the array. So this is first element, this is second element, so its position is second. So we can say 5 is our answer. So the idea is to divide the array based on a pivot element, and then we can check that position of that element matches the kth value on from the right or not. So for that so let's implement the quick select algorithm. So size of the array is nums.length array. Okay, nums.length, and initially we put our pivot at let's say we put our pivot at n-1 position. Okay, and in the array our, let's say we take the whole array. So in the whole array we will start from I is equals to 0, and we will start till our this I is greater than equal to 0, let's say. So we will find a index using a partition function. So partition function will do nothing but divide based on the pivot. So let's say our we pass our array and I and our pivot. Okay, so at the end we will check if our pivot is at the position of n minus k, then we can simply return this index. Okay, and if let's first implement the partition function. So partition function will return the uh, position of our element after partition. So this will be our start of the array and this will be our end of the array. So we will iterate our array from start and we go till less than e, because we will divide our array based on this pivot. Okay, so also we need a pointer j so that we can track how many smaller numbers we have. So if my my nums of I element, current element, if it's smaller than my pivot position, which is nums of this, then I will put it at the jth position. So what I will do, I will swap it. How I can swap? So I will find the temporary value at, store the jth value in temporary variable, and make nums of j as nums of I and nums of I as the temp, and then I can increment my j. Okay, so this is how I will find my gather my smaller element on the left. And now at the end I need to put my pivot at the center of the groups. So for that I need a temporary variable where I can find the value of j. I need to do this thing. Okay, I just need a swap of the last position, and at the end I can return that j. So that's how so in this array, basically in the first iteration my pivot will be n minus 1, which is 4, and after calling this partition function, what my code will do, it will give me array something like 4 at the center position and 5 and the 6. So that's how my array will look like after this partition. So let's print the array. Let's break it after one loop itself. Okay, so I'm printing my elements in the nums array after the first partition I have done. Okay, okay, so my array is become like this. So after first iteration, that my elements smaller than 4 are on the left side and greater are on the right side, and I will compare that index and check if that becomes equal. Then in that case I will return that position. Suppose for now I make 5 as my last element. Where are test cases? Okay, so I will replace this 4 and 5. So now my 5 will become this pivot element, and my 5 will after, let's say this is 4 and this is 5. So now I will sort around my 5 number. So this will return the correct answer this time, means this will return the correct answer. Here we can see it is returning 5 because now my 5 is in this position, which is equal to the kth position. Okay, so now I need to handle cases when I don't find any value, means the value don't match. So if my idx value, my index value is smaller, which is here, then in that case I need to move my starting value to this position, means my I pointer to this position. Okay, so if my index is smaller than n minus k, for in the case of 4, that means my answer will exist in this array. So that means my I will be equal to idx plus 1. And suppose if my index I get here is greater than n minus k, suppose it is 6. So in that case also I don't need to change my let's say my pivot, because it will already be in a greater position. So that is why I don't need to change my pivot. So I think this should work. Let's run this function. Okay, I'm getting TLE. If my IDX is smaller, IDX means my index after this position. So here it's smaller, and I'm moving my I to this position, let's say, and starting from start. Okay, so here now the pivot becomes 6. Wait a second. I think we need to handle this case, equal case. No, we don't need to handle equal case. If it's equal, then it will automatically get handled here. What I am doing, I am moving my index plus 1, my I to this position, if idx is smaller than n minus k. N minus k means this position, and idx means this position. Let's see if it's working for this test case. Wait a second, need to reset this test case. Okay, we are getting a TLE for this case. Let's print my idx value and n minus k value. Okay, so it is getting stuck on 0 and 4. Initially my idx is 3, and Okay. What we are missing here, initially I'm getting 3 position for my index, means 0 1 2 3 position for this index. Okay, it is similar. In that case I am making my okay, I need to change my pivot, not my let's see my previous submission, this one, and check what I have used here. Okay, okay, okay. In this case of this smaller, I don't need to change my pivot, as my pivot in is already be in this position. But in the case of greater, in the case it's greater, I need to change my pivot, not pivot, uh, if it's my index is greater than my n minus k, in that case I need to change my ith value to this idx minus 1. Why this is so this means suppose I want k is equals to third position in this array. I want element at third position and I choose 5 as my pivot, and I get my idx which is 5 greater than this index. So in that case I will move my I to this position, then my array will have now this answer. Okay, okay, we are getting still TLE. Need to check. mm, okay, so this is our initial array 0. This is our end position, so end position is pivot. Okay, and our pivot should be greater than 0 or equal to 0. Okay, good. Still TLE. What we are missing here? This is exactly same function. Okay. What if no, it should not work? Doing this also not work. Okay. Okay, we are getting TLE. So is this test case added just now or was it also previously? What difference does it make if I use +1 here and +1 here, +1 here, +1 here? Will it make any difference? Okay. This there is nothing. This has nothing to do with this thing. Or my this solution is still is now giving TLE. Let's see. Okay, so they have added a new test case. Means this solution is giving TLE, quick select solution. See, let's ask GPT. Giving TLE. Inefficient partition logic. You are always partitioning from 0 to I, means you do not narrow down your range effectively. Okay. and partition. Okay, let's narrow down the approach. We need to narrow down our array. Taking 0 instead. Let's first start from here. Start is equal to index plus 1. Okay. Quick select to find the kth largest element. Pivot index. Okay, so I think we should ask for a iterative solution. Provide iterative solution. Okay, so there we are using approach. Start is smaller than end. Let's call this as end, and after this we get a partition based on this end value. Okay, we have this end value. We get position of this end value. If its position is greater, if its position is greater, index is greater than position, this means we have a greater element. We have a greater element means our this element at this index, or we can say the element which is now dividing our array, is greater, and we need a smaller element. Okay, so in that case we are shifting it to this position. In the case of greater, suppose we move this to the right position. And index and starting index. Let's ask GPT. You correct dot has an issue, partition specially variable j incorrectly, which causes to behave an. Let's fix this step by step. Okay, so instead of j moving to 0, we are now moving it to s position. Okay, we are still getting TLE for this test case. Let's see if this works. No, we are getting TLE. So this is giving TLE. Okay, so basically GPT is now using a random pivot. Means partitioning using a random pivot instead of choosing it at the last as the last. Means GPT is calling another function. Let's say GPT. Now we are using the last element as the pivot. Now what it is doing is instead it is calling first random partition function, and this gives us the random pivot between these positions. Let's see if this runs for this case. Okay, e minus s plus 1. What code it's providing us? Use a math.random in place of this. Okay, so using math.random, so this will, I think this will not give us any error. Okay, so swap, we haven't initialized the swap function, so we need to copy the swap function. Let's run. Okay, random pivot is also not working. So let's see the solution section. Quick select. No, we don't need Python approach. We need Java approach. Quick select between provide a iterative version. Let's see if this works. Okay, this is also not working. I think they have added a new test case. Let's see if this code in its original form is working or not. Okay, so I think now they have added a new test case. The quick select algorithm is no more working on this particular question. So that is why we are getting a TLE. We can also copy this solution and try if this works. I think this is all. This is a C++ solution. So let's convert it into C++ and check whether if it is working in C++ or not. Then we will be sure that the random pivot is not working, means a quick select is not working. Okay, so it's working, but for which case don't know. uh, Convert to Java. What's the issue here? Okay, we are submitting in C++. We are trying to run it in C++. Shit. to read this solution. So we are using randomized pivot. I think we are using random pivot here. That's the only thing we are doing. So where's our random pivot code? This is also not the random pivot code. This was our random pivot code. So I think it's working in C++ but not in Java. I think that may also happen. Low, high, nums. Okay, nums, if it equals, it's greater, so this is the same part. Now we are calling this function, calculating random element as the pivot. So what simply we are doing here, now calling partition. What we are doing, okay, same thing. And swapping. Okay, so I think it's not working in Java only. It's the same code which we have converted from C++. So there's issue with the Java, I think, or we will debug it. I will debug it and will get to know in the next stream. So I think this is the nothing but we are generating a random number and choosing it at the pivot. So using quick select in Java, I will tomorrow I will come up with a solution. Okay, so tomorrow we will pick task scheduler and design Twitter also. Okay, so I think we can end our stream.